All right. Daniel, this is for you. Compound circuits are a combination of parallel and series circuits. Now, Emma, when I said don't take notes, I didn't mean play on your phone instead. Okay. And that was recorded. All right. So, what you want to do is chunk this and make sure you analyze no more than usually 2 or 3 resistors at a time. So if you have a string of resistors in series, you can look at that series and say, yeah, you just add those up, right? If I have a little chunk of resistors in parallel, I can go, oh yeah, I could just do that 1 over this, 1 over this, equals 1 over and solve for that. All right, you guys knew what I was talking about, right? Okay. So, in this picture, which 2 resistors do you think we should start with? And there's not an absolute way, but pick a couple of resistors that you know the relationship. The 2 and 2, correct. Very good. Good place to start. So how would I solve for the equivalent resistance just of those 2?
Equal that.
No? I appreciate the enthusiasm.
Don't ask me anymore.
It's all right. You'll hit it. 1 over R1 plus 1 over R2 equals 1 over, what is that?
Can't divide by 0, nothing.
That's a 1. That's just a bubble.
Okay.
It's a bubble. See? It's a bubble. Okay. All right. So the equivalent resistance of this parallel section is 1 ohm. Got it? All right. Now, what couple of resistors can you analyze? Which one?
The other 2.
3 and 4. How are 3 and 4 related? Parallel or series? No.
They're parallel.
They are parallel. These are parallel paths. But what about this 1 over here? What are we going to do with that? Add it to what?
3.
The whole thing.
Well, you might be able to do 3 at once, but some of us need to go a little slower. How are the 3 and the 1 related?
They are both prime numbers.
They are in a line. This is 3 and this is 1, and they are in series. What's the equivalent resistance of 3 plus 1 in series? 4. Correct. Now we have 4 is in parallel, so what's the equivalent resistance of the whole thing?
1/2.
2. Why?
Oh.
1 over 4 plus 1 over 4 equals 1 over 2, and it's the denominator. That's correct. Got it? Yeah. All right. Why don't you really, really quickly see if you can solve this, and that way you'll kind of know if you need to take, because this is just sort of crazy chicken scratches. Try this. It'll take you probably 30 seconds. See if you can get it.
Wait, what?
Some of you already have the answer, don't you?
3 ohms. Looking at it.
Okay, do we get this? Are you done? Is that what you're chatting? Let's go over this really, really, really fast. What are these 2 4s in parallel equivalent to? 2. What's the 2 and the 4 in series equivalent to? 6. So this is 6 ohms. The 6 and the 6 in parallel are equivalent to? 1/3. So it's just the denominator equivalent resistance is? 3. There we go. Half your homework is done. Do the other one. This weekend, let's play Circuit Master.